So the first part wants to find the expression for the volume of this tank then. So if this folded up, it makes a cuboid. And to work out the volume of this cuboid, it's the length times the width times the height. Now then, the height of this cuboid is x, that length there is x. The length is 8 all the way across. I'm taking away an x from each end, so that will be 8 minus 2x. And for this width, I got 5 right along, and I got an x from each end being cut off, so that'll be 5 minus 2x. So the volume, length times width times height, is 8 minus 2x times 5 minus 2x times x. So let's rewrite that. Put x at the front and the two brackets next to each other. Foil the brackets. 8 5s are 40 minus 16x minus 10x, add 4x squared. Collect the like terms, that's 40 minus 26x plus 4x squared, and then expand out. It's 40x minus 26x squared plus 4x cubed, and rewrite in the format they got it, 4x cubed minus 26x squared plus 40x. Now the second part, you could do the second part even if you couldn't get part A out. Okay, because you've got the expression for V, and what we want is find the maximum value of V and show that this is the maximum value you found. So a maximum value occurs when, for this we got a V here rather than a Y, when dV by dx is equal to 0. So work out dV by dx. 4x cubed goes to 12x squared minus, that's 52x plus 40. So the max value is going to occur when that expression is equal to 0. We can make the number smaller. I can divide by 4. So that's 3x squared minus 13x plus 10 equals 0. So that's 3x and x, 10 and 1 minus minus. So x equals 10 over 3 or x equals 1. So we've got two possible values here for stationary points. And then to decide whether it's a max or a min, I carry out the second derivative. So d2v by dx squared is 24x minus 52, differential 40 is 0. So if x is 10 over 3, the second derivative is 24 lots of 10 over 3 minus 52. So 3 into 24 goes 8, 8 tens are 80, minus 52, and that's 28. That's positive, so that's a minimum at that x value. If x equals 1, then the second derivative is 24 times 1 minus 52. 24 minus 52 is minus 28. So that's negative, so that's a maximum. So when x is 1, the volume is a maximum. So going back to my expression for the volume, I just sub x equal to 1 in there to get the maximum volume. So x is 1, v is 4 lots of 1 cubed minus 26 lots of 1 squared plus 40 times 1. So 1 cubed is 1 times 4 is 4. 1 squared is 1 minus 26 plus 40. So that's 44, take away 26, which is 18. So the maximum volume is 18, and that's occurring when x is 1.